In this video, I'm going to talk through the solutions for the review number 5 for the final exam for semester 1 of Algebra 1. The directions for number 1 say solve the equation. I know my answer should look like x equals, so I'm going to start solving by distributing first. I got to keep everything on the same side that it originally is on the equal sign. I get 5x plus 15. From there, I see that I have two variables or two linear terms on the same side, so I'm going to combine like terms. When I combine these like terms, I just get x minus 7. You could say 1x minus 7, but it's really just the same thing as x minus 7. Now I realize I need to get the variables on the same side and the constant terms on the same side. So I'm going to subtract x. I'm also going to subtract 15 from both sides. So now over here, these add to be 0. I'm left with negative 22 is equal to, these will add to be 4x. These add to be 0. Final step is to divide by 4. And I get that my final answer, if I simplify this fraction, is negative 11 halves is equal to x. So I could write my answer as negative 11 halves. I could also write my answer as, negative 5.5. I could also write my answer as negative 5 and 1/2. So we need to make sure we understand that all of these are equivalent expressions. So because over here, I see that I have a ratio and the variables in the denominator. Again, lots of ways to do this. Most of the time in class, students wanted to make that into a fraction and then cross multiply. So I'm going to go ahead and do that. Cross multiply means I would multiply the numerator and denominator of of opposites and set equal to the product of the other numerator and denominator. Gotta make sure we have parentheses around that. So from there I can distribute. I get 6 is equal to a negative 12 plus 3x. At that point I can do inverse operations to solve for x. Add 12, I get 18 is equal to 3x. Divide by 3, I get that x is equal to 6. Switching down to number 2, it says you want to join a health club for 1 year. Club A charges $25 per month and has no initiation fee. Club B has costs $50 a month and has an initiation fee of $40. So we see the two graphs. It says you can only go to the club for 3 months, which is a better deal, and explain. Well, there's a lot of ways to do this. Let's first look at the graph. If you look at the graph, you go to 3 months and you go all the way up, you see you have two options. And we need to make sure we understand which one is Club A and which one is Club B. If this one starts at 40 and then increases, the amount that would start at 40 would be the initial fee of 40. So this would be Club B. And then this one would be Club A. So at 3 months, Club A's cost is below that of Club B. So at that point, I would say Club A. So you can look at the graph. Another way to do this is to make a table. So we like making tables. It helps us see things a little bit better. So if we have number of months, and then we have Club A and Club B. Well, at 0 months, Club A is not going to cost anything because there's no initial fee. But Club B, you have to pay an initial fee of $40. At that point, we can do 1 month, 2 months, and all the way up to 3 months. So Club A costs $25 per month, so we'll do 25 and then 50, 75. It increases by 25 each month, whereas Club B increases by 15 each month, so 15, 70, 85. And we can see at 3 months that Club A would be cheaper. Another way to do this would be to look at the equations. We could write an equation. So Club A, I could say that equation would be y equals, we'll charge us $25 per month, but then no initial fee, whereas Club B would be $15 a month plus $40. So I could substitute in 3 in there, and if I substitute in 3, 25 times 3 is that 75 that we saw. And if I substitute in 3 here, we end up getting 85. So we would say that Club A would be a better deal because it costs less money. Part B says, after how many months will the cost be the same? Well, when I look on the graph, the cost will be the same where they intersect. So I could go down here and that looks like at 4 months, the cost will be the same. They'll both be spending $100. If I look over here, I could extend my table And I could see if I add 25, I get 100. If I add 15, I get 100. Once I get past that 125 and 115, we can see at 4 months they're the same cost, but after 4 months, starting at 5 months, being in Club B is actually cheaper. So after how many months will the cost be the same? We could say at 5 months, the cost is the same. We could also use those equations we had, and the cost being the same means that the costs are equal, and we could set those equations equal to one another. So subtract 15x from both sides. I get 10x is equal to 40. Divide by 10, and we get x equals 4. And all you have to remember is what x represents, and x represents the number of months. Oh, I said at 5 months. That's not correct. At 5 months, Club B becomes a better deal. Sorry, this is at 4 months. So this should be at 4 months. My mistake. All right, scooching down here, find the slope of the line. Now we talked about slope can be found in a lot of different ways. It's the rate of change, it's rise over run, it's the change in y over change in x, change in the dependent variable compared to the independent variable. Because I'm given 2 points, most people either like to make a table, and we do it this way, where we find the change in y over the change in x. So our slope would be 2 divided by -8, or -1/4. Or we like to use a slope formula, where it's y2 minus y1 over x2 minus x1, in which case you still see that we get 2 over -8, which would be -1/4. Moving over here, we have an equation. So when I'm looking at this, I remember that the slope in an equation would be our m if we can get it in y equals mx plus b, or slope-intercept form. Right now it's not in slope-intercept form, so I have to solve for y. I can do that by adding x to both sides, and I have -7y is equal to x plus 28. I need to get rid of that -7, so I can divide by -7. I can do that to all the terms. So y equals, there's an imaginary 1 there, so this is actually -1/7 x minus 4. So that's the equation in slope-intercept form. So when it's asking for the slope, then the slope would be equal to -1/7. Number 4, it's asking us to write the equation that models the function. So here we are subtracting 5 each time for f of x, or y. We are increasing by 3 each time for x. So if I want to find my slope, knowing that I need my slope, I do -5 over 3. So that's my slope. I have a couple of different options now. If I want to write the equation in slope-intercept form, I could work backwards in the table to get to the y-intercept. So working backwards, I subtract 3, I get to 0. I add 5, I get to 10. There's my y-intercept right there, so I could just write y equals mx plus b, for my slope times x plus my y-intercept. I could also use point-slope form. I got the slope. I have a whole bunch of points to choose from. Some people like point-slope form. So I could choose any one of these points. So let's just choose the first one, 3, 5. Y minus y1 equals the slope times x minus x1. Now that would be the equation in point-slope form. That's fine. It doesn't tell us what form to use. But if this is a multiple choice test, I need to make sure that I can get that to slope-intercept form if all the answers are in slope-intercept form. So y minus 5 equals, I distribute that 5/3. Negative times a negative is a positive. This will multiply to be 5. And then I can add 5 to both sides. And what we see is that we get the exact same answer. For part B, I have 2 function values, but remember, those are just like an input and an output paired up, which we could write as an ordered pair. And if I have 2 points, I know that I need to find my slope. So the slope, again, I could do a couple different ways. I'm going to do the change in y over the change in x. So my slope would be -10 over -5, which simplifies to be a +2. If I want the equation in slope-intercept form, I need the slope and the y-intercept, and what I see is that I'm actually already given the y-intercept, so I could just go right to y equals 2x minus 16. I could also use point-slope form in either one of these points, so let's use this other point, for example. Y minus y1 equals my slope times x minus x1. And I put a plus 6 because minus and negative 6 is really plus, so I jumped right to that. But if you wanted to, it would be y minus negative 6 equals the slope times x minus 5. So I can distribute that 2, and I get 2x minus 10. Subtract 6 from both sides, and what you see is that that y-intercept still ends up being the same. We get the same answer either way. All right, flipping to the back. For number 4C, sorry about the phone ringing. For 4C, we're graphing this line. I have a graph. I want to write the equation. I can see that I have a y-intercept. So I got that. It's kind of tough for me to see the slope necessarily because I don't have grid lines. But I do know that this is the x-intercept, so I could do this a couple different ways. I could see my rise and my run, so I'm going up 2, 4, 6, so pay attention to the units. So up 6, going right, roll from negative 3 to 0, 1, 2, 3, right 3. So my slope would be rise over run, or 2. Now some people would say, well, that's my y-intercept is 0, 6, my x-intercept is negative 3, 0. I could put that either in a table or slope formula. So if I make it into a table, 0, 6, negative 3, 0. Here I subtract 6. Here I subtract 3. My slope would be a negative 6 over negative 3, which is still a positive 2. So either way I have a slope of positive 2. I've identified my y-intercept as 6, so I can write the equation y equals 2x plus 6. For part D, I want the equation line that goes through this point and parallel to this line. Well, I know to be parallel, I need the same slope, and I will also need to have a different y-intercept. So we'll check that at the end. But to figure out what my slope is, I have to have the same slope as this. So my slope is going to be negative 2/3. I got to be through that point. So if I have a point and a slope, I can write the equation in point-slope form. Y minus y1 equals my slope times x minus x1. Well, minus a negative 9 is really plus 9. And now I can convert this into slope-intercept form to verify that we have a different y-intercept. Y minus 3 equals negative 2/3 x. Negative times a positive is a negative. 2/3 times 9 over 1. If I multiply that, that'd be 18 over 3, which is just 6. Add 3 to both sides. I get y equals negative 2/3 x minus 3. And there's my final answer. For part E, we're still writing equations with lines. I want the equation of a line that is with an undefined slope that goes through 8, 2. So let's sketch a graph to understand what that means. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2. Here's the point 8, 2. An undefined slope would end up being a vertical line. So I want a vertical line. When I have a vertical line, I realize that every point on this line will have an x-coordinate of 8. And the y-coordinate doesn't even matter. So this is just going to be x equals 8. For part F, write an equation of a horizontal line that goes through quadrant 3. So let's think about that. Quadrant 3, so we have quadrant 1, 2, 3, and 4. And I want a horizontal line. So horizontal would be this direction. So anything that would be like that. Now horizontal line, I remember that I'm not rising or anything, but I am running, so the slope would be 0. So it would be y equals 0x plus something, and if it's 0x, it's just y equals a number. So it can pick anything, any number, as long as it's below the x-axis, and all of these numbers would be negative. So for example, I could say y equals negative 3 would be an answer. That is one possibility, but there's other ones as well. I could have said y equals negative 2, y equals negative 10. What I cannot say is that y equals 5. That will not work because that'll be above the x-axis, and then no longer in quadrant 3. Looking at number 5, tell whether scatter plots have a strong positive, weak positive, strong negative, weak negative, relatively no correlation, then approximate the correlation coefficient. When it says this, we're saying, is R approximately negative 1, negative 0.5, 0, 0.5, or 1? Like, what would it be closest to? So when I look at this for 5A, they look pretty close to a straight line. So I would say that this would be a strong correlation because they're close to each other, and it's going downward, so I would say strong negative. The correlation coefficient, I wouldn't say R equals, I would say R is approximately, it's going to be close to negative 1. For here, these are kind of all over the place, so I would say that this is relatively no correlation, and that R would be approximately 0. It may not be exactly 0, but it would be pretty close to 0. For number 6, it asks us to approximate the best fit, the line of best fit from the graph. So when it says approximate it, meaning it wants an equation. So I'm going to sketch in a line that I think would best approximate it. We're just going to use this approximately, okay? So when I look at this, it looks like my y-intercept is about 6. So we'll say it's about that. And then I got to figure out how to get the slope of this. Now I know the slope is negative, so let me just pick 2 points on this line. Alright, so over here. Now this is not one of the actual points, but it doesn't matter. I just want to pick a point on the line. This looks like it's about 5, 3. So if I can use these 2 points, I can find the equation of the line. So to go here, I go down 3, and I go right 5. It looks like I have a y-intercept of 6, so it would be y equals a negative 3/5 x plus 6. That would be an option. It's not going to be exactly like that, but it'll be pretty close to that. Switching now, number 7 asks, what is the y-coordinate of the solution of the system? Again, there's multiple ways to solve a system. We can use the graphing, substitution, or elimination. The solution is going to be in x comma y, but this one's only asking for the y-coordinate, so I'm only looking for that part of it. I see that these equations are both in standard form, so my inclination is to go to elimination. However, both of these variables right here have a coefficient of 1, so it wouldn't take that much to solve for either one of them. I could just subtract y and have x by itself, or vice versa. But let's go ahead and do elimination here. I see this coefficient is negative 2, so this one would have to be a positive 2 to eliminate the x's. This coefficient is 4, so this would have to be a negative 4 to eliminate the y's. So I'm just going to eliminate the x's by multiplying this top equation by 2. And when I do that, I get 2x plus 2 is equal, 2y is equal to 14. I don't have to change that bottom one at all. I get negative 2x plus 4y equals negative 26. So when I add these guys eliminate. I get 6y is equal to a negative 12. When I divide by 6, divide by 6, I get that y is equal to negative 2. Now I could find the x-coordinate, that's fine, but it's asking just for the y-coordinate, so I'm actually done. If you were to finish the problem and actually find the solution, you'd substitute that back in. X plus negative 2 equals 7. I would add 2 to both sides and get x equals 9. But again, I'm just looking for the y-coordinate, so the y-coordinate is negative 2.